Then I shared one numerical. I shared one numerical on WhatsApp to calculate average atomic weight. Hope you have solved this, but still I'll explain it. You'll find this numerical in the chat box of today's video. There's a chat box attached. In the chat box, you'll find this numerical. Numerical was two isotopes of an element have atomic masses 222 and 226. Their natural abundance is 3:5 ratio. It means that if there are 3 atoms of isotope 222, then 5 atoms of isotope 226. Calculate average atomic weight of the element. So average atomic weight will be 222 into 3 plus 226 into 5, and total atoms will be 3 plus 5, that is 8. So this will give you the answer. This will come out to 224.5. Right? This will be the answer. Now, next topic. So that was about atomic weight. Standard chosen is carbon 12, which is assigned a mass of 12 units. Next, write down molecular weight. Molecular weight. Remember one thing, atomic weight is only for elements because only elements can have atoms. Molecular weight may be for elements as well as compounds because elements as well as compounds can have, or rather they have molecules. Right. MW, molecular weight of an element or a compound is the number of times one molecule of it is heavier than, remaining statement will remain the same, is heavier than 1/12 of the mass of an atom of C12, which is assigned a mass of 12 units. Mass of 12 units. For example, molecular weight of water is 18, which means that one molecule of water is 18 times heavier than 1/12 of the mass of an atom of C12. Right? So definition of atomic weight and molecular weight, these are similar. The only difference is in when we define atomic weight, we consider an atom. When we define molecular weight, we consider a molecule. And in both the cases, values are assigned in comparison with carbon 12 chosen as the standard. Since these are comparative values, that is why atomic weight as well as molecular weight, they're also called relative atomic weights and relative molecular weight. Relative means comparative, right? So write down the next paragraph. Atomic weights and molecular weights, please write down AW, MW. Atomic weights and molecular weights are also called relative atomic weights and relative molecular weights because they are assigned in comparison with C12 as the standard. C12 as the standard. Now, last time I told you about average atomic weight. Yes?
Could you repeat that sentence?
Because they are assigned in comparison with C12 as the standard. Okay. Like I told you about average atomic weight, similarly, we have average molecular weight. So next topic, next heading is write down average molecular weight. It is the ratio of mass of the mixture to total number of moles of all the components in the mixture. Total number of moles of all the components in the mixture. Now for this, I'm sharing one numerical on WhatsApp, and the same numerical I'll share on in the chat box also. If you are comfortable with the chat box, you can see there as well. So this is this. Wait a minute. I'm just sharing beta. Yes, check your WhatsApp message. You can see one numerical. It has gone 2 times, but you can see numerical is a gaseous mixture of hydrogen and ammonia contains 68% 68 mass percent of ammonia. Calculate average molecular weight of the mixture. Say mixture is 100 grams. Out of 100, it contains 68%. It means 68 grams ammonia, and remaining 32 grams is hydrogen. If I write N ammonia, it means number of moles of ammonia. And how do we convert mass into moles? Although you'll study about molar concept later, weight divided by molecular weight will be number of moles. So 68 divided by molecular weight of ammonia is 17. This is 4 moles. Number of moles of hydrogen will be 32 divided by molecular weight of hydrogen is 2, 16 moles. Total number of moles will be this plus this, 20. Now, average molecular weight is total weight divided by total number of moles. So average molecular weight of this mixture is 5. Right? Although we study about mole concept in detail, maybe we start today or maybe on Tuesday. Next topic. Vapor density. Vapor density, also called relative density. Again, since we call it relative density, it means this is also assigned in comparison with the density of some substance. Right on? Then I'll tell you. It is defined as the ratio of density of vapors. Vapors means gas. Vapors of a substance with respect to the density of H2 gas, hydrogen gas, at the same temperature and pressure. At the same temperature and pressure. Now here, to explain further, I'll have to use an equation which is included in the chapter called states of matter. And this chapter on states of matter it has been deleted after Corona. Maybe for you also, this chapter will not be there in the syllabus, but I have to use one equation to explain this topic. Keep on writing, keep on noting down everything. According to ideal gas equation, Pm is equal to dRT, or I can say D is equal to Pm divided by RT. This ideal gas equation is a part of states of matter, and that chapter you will not be studying, but this equation is very important. Sometime here and there it will be required in 11th standard as well. Now what is this P? P is pressure of the gas, pressure of vapors. M is molecular weight of the substance. R is a constant. This is called gas constant. And T is temperature. Remember, in any topic in chemistry, temperature will also always be used on Kelvin scale, right? Now,
sir, could you please repeat what each letter stands for, please?
P, pressure of gas, pressure of gas or pressure of vapors. M, molecular weight of the substance. R is called gas constant. And temperature. This temperature.
So what are we finding? What is like D over here meaning? Like, what is it? In essence, what we are finding over here with that equation?
I'm deriving one relation for vapor density with molecular weight. Right?
Okay, sir.
Because why do we call it relative? Why do we call it comparative? That will also be clear. Now I'm taking the example of, let us say, oxygen. See, for oxygen, density of oxygen will be molecular weight of oxygen into P by RT. P, R, and T I have not substituted. I have only substituted molecular weight of oxygen, which is 32. I'm taking hydrogen as the standard. So density of hydrogen will be molecular weight is 2, rest everything is same, that is P by RT. As per definition, vapor density of any substance is the ratio of density of the substance, density of vapors of that substance to the density of hydrogen, right? Hydrogen is taken as the standard. So vapor density of oxygen, I've taken oxygen. So vapor density of oxygen will be divide 1 by 2. It means 32 divided by 2. This part will cancel out. This will be 16. Now 16 is what? Nothing but 16 is half of the molecular weight of oxygen. So I can say vapor density is equal to molecular weight divided by 2. Now you can see this vapor density is assigned in comparison with hydrogen, therefore also called relative density. And remember, if standard is not mentioned, that this is with respect to, in comparison with hydrogen, then we'll always take hydrogen as the standard. If some other standard is chosen, then that standard has to be mentioned, that standard has to be specified. Right on. With example, I'll tell you. Next paragraph. If standard is not specified, then the standard used for vapor density, is hydrogen. However, if the standard is other than hydrogen, if the standard is other than hydrogen, then, now write down the formula, then vapor density is equal to molecular weight of substance divided by molecular weight of standard. See, in this case also it's the same thing. Molecular weight of the substance divided by molecular weight of standard was hydrogen. It's the same thing. With example, I'll justify that. For example, vapor density of, I'll write on the board. For example, vapor density of SO2 standard hydrogen is equal to molecular weight. Molecular weight of SO2 is 64 divided by the standard is hydrogen. If you do not specify, it's a hydrogen. So this will be 32. Vapor density of SO2 if I take methane as the standard, if I take methane as the standard, then it will be molecular weight of SO2 divided by molecular weight of methane. Molecular weight of methane is 16, right? So in that case, relative vapor density of sulfur dioxide will be 4, right? Generally, standard is not specified. That is why we take standard as hydrogen, and the relation becomes VD, vapor density is equal to molecular weight divided by 2. Now we come to average of the vapor density. Now what is that? Right on next paragraph. Average vapor density of a mixture, average vapor density of a mixture is equal to average molecular weight divided by 2. We are taking hydrogen as a standard, right? Average molecular weight divided by 2. Now, how do we calculate average molecular weight? I already told you, we solve one numerical. Now, we'll solve one numerical on average vapor density. I'm sharing this on WhatsApp. You check your message.
So I have a doubt.
Yes.
When we calculate the average vapor density, we are taking molecular weight divided by 2. But is it only when the standard is hydrogen, or if the standard changes, then the division also changes?
In that case, it will be mentioned. If nothing mentioned, that's what you have written just in the paragraph above. If nothing is specified, then understood here that the high standard is hydrogen, right?
No, sir. For average vapor density,
yes.
In that case, also the division will change as per the standard.
Will be 2. That is standard will be hydrogen. That is why I've taken divided by 2.
Okay, so usually it's hydrogen, but if the standard changes, then the division will change.
Then it will change. Of course.
Okay, thank you.
Now see the numerical in your WhatsApp message. Numerical is a gaseous mixture contains 12% hydrogen, 4% helium, and rest nitrogen. Calculate vapor density, means average vapor density of the mixture. Say mixture is 100 grams. Percent means out of 100. Very simple. 12% hydrogen. It means out of 100 grams, it contains 12 grams of hydrogen. And 12 grams of hydrogen will be 12 divided by molecular weight, 6 moles. Then it contains 4% helium. Out of 100, it contains 4 grams helium. And 4 grams of helium will be 4 divided by atomic weight. It is 1 mole of helium. Helium is 1 mole. Rest, 100 minus 12 minus 4. Rest will be 84 grams is nitrogen. and this will be 84 divided by molecular weight is 28. This will be 3 moles. So there are total 6 plus 1 plus 3, 10 moles. Total moles 10. Now, average molecular weight will be total weight divided by total number of moles of all the 3. Average molecular weight is 10. Now, average vapor density will be average molecular weight divided by 2, that is 5 is the answer. This average type is very rarely used concept. Very rarely do they use, but that's how it is. Any doubts so far?
So I didn't quite understand how we calculated the moles. How many moles for each element?
See, weight divided by molecular weight. 12% means 12 grams. Out of 100, 12 grams. 12 grams of hydrogen will be 12 divided by molecular weight of hydrogen.
Yeah.
Right? 4% hydrogen means 4 grams out of 100. 4 grams divided by atomic weight of hydrogen is 4. See, when we take up mole concept in maximum in the next class, then converting masses into moles will be very easy. Mass divided by atomic or molecular weight will change into number of moles.
No, so but the atomic weight of hydrogen is 2, right?
Yes.
So you divided that by 4.
No, I divided by 2. This is helium.
Oh yeah, that's helium. Okay.
This is helium. Please thought carefully. Okay, next topic. Atomic mass unit. Atomic mass unit. Within brackets, AMU. There's another term used for atomic mass unit, that is unified mass. Unified mass. And a new symbol for this, that is capital U. Oh, sorry, small letter U. Right. It is 1/12. It is 1/12 of the mass of an atom of C12. Such a small definition. Now, what is the meaning? Means whatever is the mass of one atom of carbon 12, 1/12 of that mass, 1/12 of that mass is 1 AMU. Its value is 1.66058 into 10 to the power minus 24 gram. This is the value of 1 AMU. So many grams is the value of 1 AMU. Right. And for any substance.
Is it pi or is it's pi, right? The number?
1.66058 into 10 to the power minus 24 gram. Right. See, I'll be uploading everything on my YouTube also in case you're not able to, sometimes if you're not able to listen correctly, you can listen to video rather than we keep on repeating everything, because there is internet problem everywhere. I have strong internet, but maybe some problem at your end.
Sir, could you also share the link of your YouTube?
I've already done that, man. I'll do that again. It's better
Thank
we do not talk about all, see, it's better we do not talk about all these things in the class, during the class, because this is being recorded. Do that in WhatsApp. After the class, WhatsApp, you ask me any damn thing. Because if we keep on wasting like time like this, it will take 1.5 years to finish the syllabus. It's voluminous. We have almost not started chemistry. Almost not started. Okay, carry on. So I told you about what is the meaning of AMU, atomic mass unit. This is 1/12 of the mass of an atom of C12. And I gave you the value also. Right. Thus, for any substance, write down number one, weight of one atom किसका होगा? एटम, एलिमेंट का. Weight of one atom is equal to its atomic weight in AMU. For example, weight of one atom of oxygen will be, what have you written? Its atomic weight in AMU. That will be 16 AMU. 16 is the atomic weight of oxygen. So I can say mass of weight of one atom of oxygen is 16 AMU. And if you want to express this in grams, then I can say this is 16 into 1.605 value 1.66058 into 10⁻⁻24 gram. So I multiply 16 by the value of 1 AMU. This will be the mass of one atom of oxygen in grams. Now we take the example of a molecule. Number 2. Weight of one molecule is equal to its molecular weight in AMU. For example, one molecule of water, molecular weight of water is 18. It means one molecule of water will be 18 AMU. But if you want to know its mass in grams, then multiply by the value of 1 AMU. So I can say this is 18 into 1.66058 into 10⁻⁻24 gram. This is the mass of one molecule of water. Further write down. Similarly, let me write on the board. Similarly, 64 grams oxygen. I have not mentioned whether the 64 grams of oxygen is O2 molecules or oxygen atoms. 64 grams of oxygen is equal to, if we divide by atomic weight 16, then it will be 4 AMU. No, write it AMU. 64 AMU oxygen will be 64 divided by 16, 4 atoms of oxygen. But if I divide by molecular weight, 64 divided by 32, it will be 2 molecules of oxygen. Think the reverse way. One molecule of oxygen will be 32 AMU. It means 2 molecules of oxygen will be 64 AMU. Similarly, one atom of oxygen will be 16 AMU. 64 will constitute, or I can say 4 atoms will have a total mass of 64 AMU. So this is the relation to convert the given number of AMU into number of molecules or number of atoms. To convert into atoms, divide by atomic weight. To convert into number of moles, divide by molecular weight. Again, a very rarely used concept these days. Next topic. Percentage composition. Percentage composition. It's a very simple topic. Let us say in a class, in a class of 20 students, let us say there are 12 boys and 8 girls. Then what is the percentage of boys? 12 divided by total, that is 22 into 100. Similarly, you know, an element, a compound is made up of 2 or more different elements present in it. Then what is the percentage of each element in the given compound? That we can calculate by using the same type of formula. So first, what is the meaning of percentage composition? Right now, percentage composition of a compound, percentage composition of a compound is the number of grams of that component, number of grams of that element. Component, you may get confused. Number of grams of that element present in 100 grams of the compound. It can be calculated by using the formula. I'm telling the formula how to calculate percentage of each element in the given compound. Adam? Element percent. Element percent means percentage of an element in the compound is equal to its contribution in molecular weight. I've written its contribution in molecular weight divided by molecular weight into 100. Into 100. So this is the formula to calculate percentage of each element in the given compound. I'm sharing 2 numericals. We'll solve these 2 numericals. Yes, these are on WhatsApp now. Numerical number 4 and 5. Yes. Calculate percentage composition of NaOH. Look here, how do we calculate? For that, first of all, we'll have to calculate molecular weight of NaOH. And how do we calculate molecular weight? Sodium, atomic weights will be given, right? 23, oxygen, 16, hydrogen, 1. Total molecular weight is 40. So percentage of sodium will be contribution of sodium divided by molecular weight into 100. It comes out to 57.5%. Then percentage of oxygen. Contribution of oxygen 16 divided by molecular weight 40 into 100. This comes out to 40%. Percentage of hydrogen. Contribution is 1 divided by 40 into 100, 2.5%. And naturally, sum of the percentages of all the elements will be equal to 100. If you add all the 3, it will be 100. Right? Now, there's one more numerical in your WhatsApp. We'll solve that one.
So there's no in the WhatsApp group कोई numerical आया नहीं है sir.
Sir, I cannot also see.
Yeah, and the previous numerical which you sent about the average.
Wait a minute. Oh yes, I've sent in some other group.
Yeah. The previous numerical about the average wall.
I tell you, since you're अरे यार, since you're interrupting so much, तो problem हो गया. It has all the numericals have gone to another group. I'm forwarding. Yes. Can you see now? Have you received? Still not?
No, sir.
Oh God. There may be some network issue. Let's. It's not going from my end even. Can you see in your in the chat box of today's class? You know how to check in the chat box?
Sir, we can see the Intext Numerical-02.
Yes.
Yeah, we can see that.
Okay.
None
And
of the new
now,
ones.
can you see
Yes, sir,
number
we can see
4,
now.
Yeah,
4
now
and
we can
5?
see. Now, yeah.
3 is probably missing, that I'll upload later on.
So we can see 4. We can't see the 5th one.
Fifth is also there in the same message.
Can you see now?
Yes, sir.
Yeah.
It is also there in the chat. Calculate the percentage of oxygen in washing soda. Washing soda is sodium carbonate decahydrate. So Na2, CO3, 10 water. First of all, how to calculate molecular weight? If the molecular weight calculated is wrong, then entire numerical will be wrong. Sodium. These are 2 atoms, 2 into 23. Carbon, 1 atom, 12. Oxygen is, can you tell me how many atoms of oxygen are present? How many atoms of oxygen are present?
13.
13.
13. So oxygen is 13 into 16, 208. Then hydrogen, 20 atoms of hydrogen into 1. This is 286. We have to calculate percentage of oxygen. The percentage of oxygen will be contribution of oxygen divided by total molecular weight into 100. This will be 72.73%. Right, that's how we'll calculate percentage of any element present in the given compound. Right. I know you are probably overexcited because you have come to the proper science stream now. Just relax. You'll learn everything. You have to have patience. You have to have patience. And in case you are not able to listen to a particular word carefully, first of all, you should be fast in writing. Your network should be strong. Otherwise, it will be difficult. And in case once in a while you're not able to listen to a particular word or two, then I'll be uploading these classes on YouTube also. Right? I'll share the link in case you have not received. I'll share again. And if I do not upload today, maybe in a day or two, these will be there on my YouTube channel. Okay. Next topic. Without this topic, we cannot learn chemistry. That is mole concept. Mole concept. Listen, if we take 12 grams of C12, if we take 12 grams of C12, how many number of atoms are present in that amount of C12? That number is called 1 mole. So what is 1 mole? 1 mole, I can say, is the number of atoms or number of particles present. See, the same number of particles present as present in 12 grams of C12, that is called 1 mole of any substance. If I say that particular number is called Avogadro's number. You know the value. I'll tell you this value. If that many number of oranges are there, it means this is 1 mole of oranges, right? Right on. Mole is defined as the amount of substance, amount of substance which contains as many particles. When I say particles, it may be atoms or molecules, which contains as many particles as the number of atoms present in 12 grams of C12 isotope. Present in 12 grams of C12 isotope. Value of this number is 6.022 into 10 to the power 23, which is called Avogadro's number. And the symbol for Avogadro's number is Na, subscript A, Na. See, like we say, 1 dozen is 12 units, 1 dozen oranges, 12 oranges. 1 score is group of 20 items. 1 score bananas, 20 bananas. Similarly, 1 century, 100. These are units of counting. Similarly, Avogadro's number is a unit of chemical counting. It's a unit of chemical counting. If I say 2 moles of water, it means 2 into this value, so many molecules of water. Right? Now, if we are given the mass of a substance, like we have used in previous numericals, if we are given number of atoms of something, if you are given number of molecules of something, and number 4, if you are given volume of a gas, these 4 can be converted into moles by formulas which I'm giving you now. Write down. 6.022 into 10 to the power 23 atoms is 1 mole, and it weighs equal to atomic weight of element in grams. Atomic weight of element in grams. So if I say so many atoms of oxygen, it means 1 mole of oxygen atoms, and the mass will be equal to atomic weight, and that is 16 grams of oxygen. Right. Similarly, 6.022 into 10 to the power 23 molecules is 1 mole, and it weighs equal to molecular weight of the substance. is equal to molecular weight of the substance. See, first of all, you should imagine how big this number is. If total population of the world is this number, then people will have to stand one above the other in many layers. If there is no water on earth, if these people, so many people stand one above the other, they'll form a multi-layer. That is 1 mole. If total water in oceans is represented in milliliters, not liters, milliliters, that figure will be much less than this figure. It's a huge number. If I have, say, 1 mole of rupees and I start spending this amount at the speed of 1 crore per second, if I spend 1 crore rupees in 1 second and I have just 1 mole of rupees, so many rupees, I'll have to live millions of lives to spend this money at this speed. So this is a huge number, and this is the chemical unit of quantity. Next paragraph. Now I'm telling you relations. Mass of a substance or its number of particles or volume of a gas can be converted into moles as given below. Can be converted into moles as given below. I'm giving you 4 relations to convert this into moles. So number of moles for number of moles, we use the symbol small n. Weight of atoms divided by atomic weight. Remember like this: atoms, atomic weight; molecules, molecular weight. Right? Second relation, weight of molecules divided by molecular weight. Third relation, number of let us say particles divided by the value of Avogadro's number. Now this particle may be atom, may be molecules, may be person, may be number of cars, anything. So number of particles of anything, any substance, divided by 6.022 into 10 to the power 23, that will be number of moles. If I say 10 cars, how many cars? 10 divided by Avogadro's number, so many moles of cars, right? And the last is volume of a gas in liters. I'll read it out for you. Volume of a gas in liters at STP. STP, I'll tell you, divided by 22.4. Divided by 22.4. Now, what is STP? Write down. Full form of STP within brackets: standard temperature and standard pressure. So ST is standard temperature, SP is standard pressure. Further write down, although this will come later in next class, standard temperature is equal to 0 degrees centigrade and standard pressure is equal to 1 atm. Atm is the unit of pressure. This is called atmosphere. 1 atm. So if we are given the mass of atoms, mass of molecules, number of particles, if we are given volume of the gas in liters at STP, we can convert into moles by using any one of these formulas. Next topic. Gram atom and gram molecule. Gram atom and gram molecule. Listen. If we say 2 moles of oxygen atoms, then I'll say 2 gram atoms of oxygen. So number of moles of atoms of anything, number of moles of atoms of anything will be number of gram atoms. Similarly, number of moles of molecules of anything is called gram molecules of that substance. Right on. Number of moles of atoms is called gram atom, while number of molecules number of moles of molecules is called gram molecules. For example, 64 grams of oxygen may be, now we'll complete the sentence later, listen carefully. Let us say I have 64 grams of oxygen. How do I convert into number of moles of molecules? Look at the 4 relations which I gave you above. 64 grams of oxygen will be how many moles of molecules?
Four.
Yes, divide by molecule. When I say number of moles of molecules means divide by molecular weight. So divide by molecular weight, that is 32. Oh, sorry, 64. Right? So it will be 2, not 4. Number of moles of atoms will be 4. Right?
Yeah.
Number of moles of atoms will be 4 because in that case I divide by atomic weight. So this 64 grams of oxygen, either I can say this is 2 moles of molecules, or I can say 4 moles of atoms. And in the context of present this topic, I can say the 64 grams of oxygen will be, either I can say this is 4 gram atoms of oxygen, or I can say it is 2 gram molecules of oxygen. Right? So continue with the sentence. For example, 64 grams of oxygen may be 4 gram atoms of oxygen, or 2 gram molecules of oxygen, or 2 gram molecules of oxygen. Now again, I'm sharing one numerical. I'll try on WhatsApp also if it works. Just check your WhatsApp, it has come or not. Otherwise, I'm sharing in chat box.
That's where it's come.
It has come? Okay. See, this is calculate the number of atoms in 2.8 into 10 to the power minus 9 milligrams of nitrogen. Now, listen carefully. How do we solve this? I gave you 4 formulas for calculating number of moles. I have to calculate number of atoms. Out of those formulas, can you see there's one formula in which we talk about number of particles? Which one is that? It is number of, in this present numerical, particles are atoms. Number of atoms. Tell me, what is the denominator?
Avogadro's number.
Avogadro's number. And the question says, in so many milligrams of N2. Tell me, N2 is element or compound?
Compound.
Sorry.
It's a molecule.
It's an element.
Molecule.
It's atom or molecule?
It's a molecule.
Molecule.
Molecule. We are given weight and weight of molecules. One of those four relations is weight divided by molecular weight. Can you see there? Out of four.
Yes.
So this is weight divided by molecular weight. Now, number of atoms we have to calculate will be equal to weight is given. This is 2.8 into 10 to the power minus 9. 10 to the power minus 9 is milligram. I've converted into grams. Becomes 10 to the power minus 12. Multiplied by Avogadro's number. Divided by molecular weight of nitrogen, that is 28. Before I tell you the answer, first of all, tell me, could you understand? Out of four relations, for number of moles, I equated two of them. Because we have to calculate number of atoms. So I use the relation number divided by Avogadro's number. We are given the weight and we are given the weight of molecules. Therefore, weight divided by molecular weight. We are given the values, or we know the values of these three. Fourth, we have to calculate. So answer in this case will be 1.2044 into 10 to the power 11. So many atoms of nitrogen. Right? Children, with that, we finish the class. Please, one thing. If not immediately after the class, in a day or two, I upload these classes on the YouTube channel. This naturally will be a long video. At the same time, I make short videos also. This video will be too lengthy for you to listen to because it will be 1 hour video. I'm dictating. The other short video will be in which I'll just explain. There's no dictation. That will be short video, but we'll be covering a lot of content in that short video. So listen to those videos. In case something is left, you miss out something, you can note down from there. Otherwise, you can call. Rather than, because these videos when uploaded will be seen by everyone.